Aloha and welcome. In this video, we're going to be talking about database security. So databases are used often on web application backends to store information. That information can take a variety of shapes. It can be information that you're storing about a user. It could be just selections of items that they've purchased in the past. It could be anything. Some of this data is going to be sensitive. Some of this data may not be sensitive. So given that, we want to prevent against data exposure. Data exposure is the intentional or unintentional disclosure of information to unauthorized users or applications. So how do we go about preventing data exposure with our database information? Well, we have a number of methods. One is normalization, another is stored procedures. We also have encryption, we've got salting, and we've got hashing. So let's go through those in order. So the first thing we're going to talk about is database normalization. And that's the process of organizing data in a relational database. So when you store information, you want to store it granularly. And when I say granularly, what I mean is you want to have one piece of information in each field. You don't want to be putting multiple things in there. You want to normalize it so that you've got just one piece. They use an example in the book that, let's say in their product, they have your product ID, which is the unique identifier. Some people call it a key, a primary key, something like that. Then you have a field, like color. Then you have price. And for color, you may have two different colors that have the same price, but you don't want to have those in just one record. You want to break that up into two records. So one way you can do this in a product table, instead of having product, color, and price in there, what you can do is you can have one for color and then one for price. In the color one, you're going to have each product ID, you're going to have product ID, and then you're going to match it to a color. So if you had a combination in there, like black and green, you would break that into two items instead of the one that we're normalizing. So instead of having it black and green having a price of $3, you'd have black having a price of $3 in one row of your record, then green having a price of $3 in another row of your record. So this is called normalization. It's removing the redundancy. And when we talk about database normalization, in general, you don't want information stored across all areas of your all areas of your database. You don't want it in the same information in multiple tables. You don't want repetition of, let's say, user name or user addresses, things like that. So you want those located and isolated into one section. So there's reasons for that. One is that if you were to able to get to the same information through two different ways, and one's protected, the other's not, you can get to that information. The other is that in general, having duplicates of information, it means that you have synchronization concerns as well. You have to make sure that if you've got the address that's in two places, what happens if the address changes? Then there's all kinds of programming considerations we don't even get into, like when you ship it to somewhere, should you just have the address showing in the historical record be where it was sent to at that time? Or what if they change the address later? Should you have that old record, of that shipment, retaining where it was originally shipped to, or should you update it with that address? There's all kinds of considerations here, but that has to do with your data governance. But that's not in the scope of what we're talking here. What we're talking about here is data normalization. Data normalization is just the practice of isolating information, hopefully into one area, so we're not duplicating that information. So that's data normalization. Next, we're going to talk about stored procedures. So stored procedures are nice because that's a group of SQL statements that are going to perform a specific task, and it's stored, as it says, stored procedure, it's on the database side. So instead of us in the back end of our program sending off query by query to do a bunch of things and probably accepting user inputs to form those queries, what we're going to do is we're going to have a stored procedure which exists over on the let's say, a SQL server, whatever your database server is, could be Postgres SQL, MySQL, whatever it is. You're going to have a stored procedure over there. And the nice thing about stored procedures are they support parameterized queries. So parameterized queries, what does that mean? Well, a query itself is when we ask the database something. We query the database, we say. So we form we form a query. A general query would be select, and this isn't the best way to do it, but select star, which means everything, get everything from table name. We'll call that orders. And then if you want conditionals, you can say where first name equals John and last name equals Johnson. So that's a query in general. A parameterized query is where we're going to be setting up everything except the values that we put in there. So when we call in a stored procedure that's using parameterized query here, what we're going to do is we're going to call on that and we're going to give it the values that we're going to be sending in there. So that helps. It helps in a number of ways, but one, it's going to reduce the traffic that goes back and forth between the back end of the server and the database. The other thing it's going to do is it's going to help minimize the risk of SQL injection by removing the need to create SQL queries based on the user input. So that's why we like using stored procedures as much as possible. The other thing to talk about is database encryption. So in general, databases, we don't want to encrypt the whole thing. There's a lot of information there that isn't sensitive. There's some information that is. So we're going to look at what is the most efficient way of encrypting and protecting our data. So we need to identify the data that needs protecting. And we've got two different ways of selectively encrypting. One of them is going to be column level encryption. Some people call it columnar encryption. The other is going to be the record level encryption. So the columnar, the column level encryption, we're going after fields. So let's say we have a user database, and one of those fields is social security number. And that's personally identifying information, PII. This is very important stuff. It's very sensitive. We do not want that leaking. So in this case, it would be a good idea to encrypt that field. We don't need to do the first name, the last name, and things like that. That's not going to give us, that's not PII. We want to make sure that our, very important fields are encrypted. So we're going to be encrypting those using columnar encryption, just field level. The other level is going to be record level encryption. Record level is when you need the entire record. And when I say record, all the information that relates to this, let's say it was a personnel thing. What if everything about that person was, needed to be, encrypted? Let's say it was a medical record or something like that. All that information is PII. You don't want that, like condition and date of, date of admittance, things like that. All that is sensitive, and so that entire record needs to be encrypted so that others don't get it. So we would use record level encryption for that. And there's a chart in your book to go over things like that. What are the advantages that we have to doing this? So on a column level, you're doing it efficiently. You're only aiming at, certain ones. Record level, because you're doing the entire record, of course, you're doing all the different, fields there. So that's going to be a little bit more expensive in terms of overhead, but it's still better than encrypting your entire database. So that's the in between there. Security considerations you need to worry about. With a column level, that's going to be used in a database where you have mixed sensitivity levels. Let's say you only have maybe one or two fields that need to be encrypted. So that's a good use case for columnar encryption. But for record level, that's best if most of the information in that record is sensitive. So keep that in mind. The next thing we need to talk about is secure storage techniques. And when you're saving data into a database, particularly we're talking about passwords here. When you're saving information like a password, you don't want to save the password itself. If you ever go to a website and you have to reset your password or something, if they allow you to change your password, or if you have it where they email you what your password is, if you give some information to them, that they're saving this information, and they're not hashing it. The better way to do it is to hash the information. You don't want to save a password in the database. You want to hash it, because remember what a hash is. In a hash, you're going to be taking the password, and a hash takes a variable length that could be any size. So it takes this whole thing and it comes out with a fixed size. let's say 8 characters or 16 or 256 characters, whatever it is, it's going to come up with this message, this, let's say 256 character hash. And after it comes up with this hash, you can't reverse that process. So instead of saving the password, what you can do is you can have the hash of it, and then at the other end, when a person goes to submit their password for verification, takes their credentials, and then it just runs the hash on it. And if the hash function, it's going to be the same hash function. The hash function comes up with the value that you have in the hash. You know that their password matched. You don't even need to know what their password is. You just need to know that once you run that hash on it, that it comes out to the same message digest at the end of it. So that's how we check that. Another thing that we do is we salt these as well. So salting is the process of adding a little bit of something to each password so that when they get, let's say my password was doggy, then what we would do is we would add some characters to that. So salting, it's the process of adding a unique string of characters known as a salt to a password before hashing the password. So you're going to take that doggy, you're going to add the hash, whatever it is. It could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, even though that's horrible to do. You could just add whatever characters it is. Then you take that combination, then you hash that. And the salting, it's going to protect against brute force attacks that use rainbow tables. So rainbow tables, again, this is something you probably haven't heard of, but rainbow table, it's a pre-computed table of hashes for common passwords. So if they're using this rainbow table and they don't know what the hash is because the hash is randomly generated by your system. So if they don't know if they don't know what your hash is, they're not going to, that rainbow table is going to do them no good because it's taking doggy, kitty, tiger, whatever the passwords are, and it's making a hash out of it. But if you've been adding in like 1, 2, 3 at the end of each one of these, it's never going to hit with the rainbow table. So that's why we do salting. So salting just adds you a little bit more protection when you're hashing your passwords. So that's it for this section. If you have any questions about it, feel free to reach out to me. A quick recap of what we just talked about. We're talking about database security. We're talking about preventing data exposure. How do we do that? We do that through database normalization, making sure that you don't have redundancies in your data throughout your tables. We talk about using stored procedures, particularly parameterized queries to these stored procedures so that we lessen the chance of SQL injections. We talk about encrypting at both the columnar, the field level, as well as the record levels. And we also talk about secure storage techniques like salting. And salting is going to prevent rainbow table attacks. So anyway, that's it for this video. I hope you enjoyed it. If you have any questions, feel free to reach out and I'd be happy to help you. Aloha.